Hello everybody, Dr. Matthew Courtney here. In this video I'll be providing an introduction to the R programming environment, the basics. Okay, what is R? R is a programming language for statistical computing and graphics created by New Zealander Ross Ihaka and his colleague Robert Gentleman in the 1990s. Unlike other statistical software programs, R is free and open source, meaning anyone can use it and make modifications. Officially, it has a general public license version 3 and can be considered a public good. RStudio is the popular general user interface, and it has 4 main panes. Here, the source editor, the console, the environment, and the files, plots, packages, help pane. Basically, the source editor is where we write code to do analysis and make notes. The console lets you know if you made a mistake. The environment here is where you store important data and results. And the files, plots, packages help pane helps you to choose your method of analysis and view graphs, for example. I'll cover these 4 panes in more detail in another video. So, what's the big deal? Statisticians around the world make special statistical modules, shareable code called packages, and make these freely available. For example, my colleague and I, Dr. Chang from Auckland, we made a package called Normal R. You can see this package here because I downloaded it. There's the package here. There's the documentation for the package. Here are the different functions. So this is the function normalize, which helps you to normalize your data so that there aren't many outliers. And so this is the function of the normalize function of the normal R package. And we give notes about how to use that package here. The usage and some examples that you can cut and paste into your console. So you'll note that there's lots and lots of packages here, and some of them are turned on so that I can use them inside my console. So by crowdsourcing statistical procedures, R has a very wide variety of tools to apply to educational data. As of February 2022, it has nearly 19,000 unique individual packages. R is currently the most popular statistical software program in the world for quantitative researchers. It's used in graduate schools of business, graduate schools of public policy, social science and humanities, and so forth, to teach research methods, and all the researchers, many of the researchers are using this software program. So at this point, I'd like to just move to a section of a paper, a white paper that I've written on the use of statistical software programs in research. So all software has a life cycle, and statistical software programs are no different. One way to understand the relevance of SSPs for research is via bibliometric analysis and an analysis of the use of SSPs in the Scopus database, which is the preeminent archive of authoritative research, reveals that R became the most popular statistical software program for researchers around 15 years ago. And today, 75% of quantitative research is undertaken in R. So here are our big 4 software options over the years. And since 1995, there's been different cycles, you could say. Before 1995, SAS, an American commercial software made by SAS Industries, was very popular. From 1995 to 2006, SPSS was most popular. Nowadays, we note that R has become the most popular tool for quantitative researchers in the world. Okay, so how is it maintained? It is maintained by the Comprehensive R Network, called CRAN, which is R's central online software repository. So the CRAN members, the specialists, maintain all packages created by the statisticians. So if there's a bug that isn't corrected in those packages, the CRAN members, those specialists, will take that package down. What is a package exactly? So I showed you one example of the package that my colleague and I wrote, but let me give you an example of some more basic packages. So a package is a single unique statistical module. By default, R comes with 14 standard packages. If I want to find the mean and standard deviation of any series of numbers, I can use the base package's mean function and the stats package's SD function. So first, let's consider how a series of numbers is written in R. For example, these might be student quiz results out of 10 for 6 students in a class. The numbers are combined with a C in the following code. So if I run this, we can see that this is just one line or one dimension, and we see that there are 6 different elements of that numeric vector. So this is actually called a numeric vector. Numeric meaning related to numbers, and vector, which is another name for a single series of numbers. So if I want to find the mean, or the arithmetic mean, of this series of numbers, I would put these series of numbers inside another set of brackets here. You can see this first bracket is linked to the last bracket. I write the name of the package, base. I write the function, mean, and it's separated by 2 colons, so that the computer knows exactly what I want to do. I want to use this package, this function, to analyze this data. I would highlight and click Run. And I get the result, 7.67 approximately. If there's an error or something, I can check the package information. I would write base here, click on base, go to the mean function, note that this is the mean function of the base package. It gives a description, shows you how to use the function, shows you the arguments that are used inside that function. The first argument is a numeric vector, which is a series of numbers. Excuse me. We also have references and also examples. Here you could copy this code here into your console and have a play with it. Again, the stats package and SD function, same thing. I would write stats here, look up the SD function, here, note how to use it. The first argument that you need to use is a numeric vector. And there's some examples here as well that you can copy into the console. Anyway, of course, if you wanted to find the mean and standard deviation of a variable in your spreadsheet from the research that you've already undertaken, you would not need to enter all the numbers here. You would simply read in the spreadsheet into RStudio and analyze the data very quickly. Okay, some notes. When a line starts with a hash, it cannot perform any function. So if the line here starts with a hash, it becomes just words. There's no output in black. Nothing happens. But if I write something here, it's no problem, because it's to the right of the mathematical functions. Again, no problem. Okay. In summary, R is the most popular statistical software program for doing quantitative research. There are four main panes: the source editor, the console, the environment, and the files, plots, packages pane. We analyze data with a packages function, e.g. base and mean, and then we wrap everything, the numbers, with brackets. We highlight and we run. That actually worked because we're only highlighting something that works. Anyway, write some new numeric vectors, e.g. the ages of 5 of your friends, and try the following functions here. Try the min, max, and range functions to see what happens. Okay, that brings us to the end of the video. Thank you very much, and stay tuned for some more videos. Thank you.